So the screen might, it might disconnect me a couple times throughout the period, so just bear with me on that. But I should fix the purple thing that was going on there. Okay, so I want to talk about combining functions. Okay, on Friday we kind of ended with this idea here. And it's basically saying that no matter what your functions are, f and g, you can add them by just taking the two functions, slapping a plus sign between them, and you're good to go. Okay? You can subtract them doing the same thing. Just make sure that you understand when you subtract them, if your g function, which in this case would be the one that you were subtracting from f, if it's multiple terms, then you've got to subtract that quantity, right?
Yes.
Okay, so you got to distribute a negative. Same thing happens if I go g of x minus f of x, and my f is multiple terms. We kind of talked that addition is commutative, so f plus g is the same thing as g plus f. And we talked about subtraction not being commutative, so f minus g is not the same thing as g minus f. And we got this multiplication. Multiplication then, obviously multiplication is commutative, so f times g is the same thing as g times f. Okay, and in all of those, we did the domain as the intersection of a and b, where a was the domain of one of the functions, they call it f, and then they say that b is the domain of the second function, g. So the domain of combined functions is the intersection of each of the functions individually. Okay. What you want to do is make sure that when you're determining those domains, is that you determine them prior to any simplification. Okay? Especially when there's roots, especially when there's division with your individual f or your individual g. Because through the simplification process, you might generate a new function that visually, algebraically, looks like there are no domain issues, where if you graphed it, there would be. Okay, so kind of expand on that idea real quick here. If I were to take, let's just say, we'll just do one that's really kind of simplistic. Let's say f of x is equal to square root of x. Let's say g of x is equal to square root of x, and that's fine. Okay, you can have two functions, f and g, that are actually the same. Okay, if I were to do f times g, f times g of x, it'd be root x times root x, which gives me what? Just x. Okay, so if I did that, now I ask myself, well, what's the domain? And I look at the domain of just x, I might think that there's no problems there, right? There's no roots and there's no division. But this rule says, this definition of how we combine functions, says it has to be the overlap of f's domain and b's domain. Well, what was f's domain? Bigger than or equal to 0. What was g's domain? Same thing. What do they overlap then at? Same thing, right? 0 to infinity, including 0. If I were to take this in GeoGebra, okay? So let's just go f of x is equal to square root of x. G of x is equal to square root of x. And now I ask it to do f times g of x. I do it this way. F of x times g of x. It gives me that line right there. Which now GeoGebra knows well enough, because I'm doing function arithmetic here. It knows not to kind of simplify that. But if I look at that blue line, is that blue line the same thing as y equals x? Yeah. Yeah, but it's only what portion of it? The positive, from 0 to infinity, right? And that's because of the domains that function came from. Okay? Think about this. What we're doing, when I say f of x times g of x, I am taking the y values. Okay, so I'm taking, let's say that, let's go out here to 4. So x is 4. The y value here would be 2. So f of 4 is 2. G of 4 is 2. Does that make sense? Okay. When I say f times g of x, what I'm saying is when x is 4, I'm taking f of 4 and multiplying it by g of 4. Does that make sense? Well, f of 4 is 2. G of 4 is 2. If I multiply those two things together, I should get 4, which was the x value, right? Does that make sense? Yeah. Now, here's the reason that I can't do that over here. What's f of negative 2?
Nothing.
What's g of negative 2? Now, careful. I'm saying nothing because nothing elicits a number to me. Undefined. So undefined times undefined gives me...
Undefined.
Maybe.
Error.
Depends on what that undefined value is. It's not defined. We don't know. Okay? It's undefined. Okay? So because it's undefined, you don't see then that blue graph to the left of 0. Does that make sense to everybody? And that's the idea of these domains as we work through. We can only graph where both domains exist. Okay? One thing about division then, okay, not only do we have to pay attention to the intersection of the domains A and B, okay? So no matter whether I'm adding, subtracting, multiplying, or dividing, I'm always going to be looking at the intersection of the two domains, right? Okay? So in your homework, you're going to see, and even on the test, there's a question, 15 I think it was, that asks you to do this. Might not have been 15. Give you the specific number. It is 15. So number 15 on the practice test actually gives you two functions, f and g, and it asks you to come up with f plus g, f minus g, f divided by g, and it asks you the domain of all those things. My hope is that you don't do the domain 3 separate times. The domain, no matter what you're going to do, add them, subtract them, multiply, and divide them, the domain is always A intersect B. However, when division occurs, you have one added aspect, is that your bottom function cannot be 0. G of x is not allowed to be 0, so you need to incorporate that. Does that make sense? The way we read this, it says x, your domain, your x values, are elements of A intersect B. Well, A intersect B was a domain, right? So x is an element of that domain that says such that g of x cannot be 0. Okay? So your function g of x is not allowed to be 0. That's how we would read that phrase down there. And kind of in layman's terms, all that means is when you are done writing what f of x over g of x looks like, make sure that there's nothing extra on the bottom that needs to be kicked out. Okay? On your practice test, number 15, looks like this. It says f of x is equal to x squared minus 25. G of x is equal to 1 over root x. Okay? So this is, when we're talking about domains, just kind of staying consistent with how it was defined in that blue box. That would be maybe domain A. This is going to have domain B. What's the domain of anything that's polynomial? All real numbers. Okay. What is the domain down here for g of x? Okay, greater than 0. Good. Okay. Can't divide by 0. So that's why we had to kick that one out. So now, no matter what, if I ask you what f plus g is, f minus g, f times g, or f divided by g. I'm not going to write f divided by g because there's a little bit additional information there. But the domain is going to be the overlap of those two things, the intersection. Well, where do they overlap? 0 to infinity. Once I determine that, that's the domain for f plus g, f minus g, f times g, g times f, g minus f, g plus f, f divided by g, g divided by f. And it's the starting point, I guess, for f divided by g and g divided by f. Because when I'm done, when I actually write them, I got to make sure that I can't have 0 in that denominator. So, I'm going to, so if they ask you f plus g, I'm going to go 1 over, we'll go in order that it says. Doesn't matter, though. Be x squared minus 25 plus 1 over root x. That's all you got to do. You take the two functions, you slap a plus sign in between them, and you're done. Okay? Some of them you'll want to simplify. And the reason we would want to simplify some of these is for the purpose of graphing, okay, and creating ordered pairs and recognizing maybe patterns that we can use to graph things. If I was going to simplify this one, I would need a common denominator of a radical x on the bottom. And when I go through that process, my result to graph really isn't any more difficult, more simpler than this one. So I'm just going to leave that one alone. I'm not going to simplify it. On the test, I'll tell you whether you need to or not. Okay? Yes?
Wait, so is that the domain for f divided by d2 or no?
It's the starting point for it. Okay? When we're done, we got to when we write f over g and g over f, we got to look to see if there's any additional things that pose an issue. F minus g then, so f minus g would be what, x squared minus 25 minus 1 over root x. Okay. Let's do real quick g minus f.
So isn't the x problem from x?
Yeah.
Now I know the answer.
Okay. So g minus f, remember this would be 1 over root x minus, now it's a quantity. Okay, you can leave it that way if you want to, but I would suggest distributing that negative through. But my hope is that we see that f minus g and g minus f are not the same. In your homework, they're going to ask several questions like that, and they're going to say, okay, here's two functions. Here's f minus g, here's g minus f, and they're going to ask you to make an argument about them. And it's basically that the commutative property does not exist with function subtraction. Yes?
Wait, so does it matter, like, do they still have the same domain, like both of them?
Yes.
Okay.
Yes. Okay. So far in all of those, the domain is still 0 to infinity. If I do g times f, write it this way. G times f of x, okay, that's going to be 1 over root x times x squared minus 25. Okay, so that gives me x squared minus 25 over root x. Okay, still the same domain, still 0 to infinity. Now, the only thing that I would be cautious of here is just pay attention. I don't know if this will ever happen, but just pay attention to that bottom. It's still division, right?
Yeah.
So if for any reason my A intersect B would have included 0, in G times F it should exclude 0, right? Okay, just be cautious. I don't think it should be a big issue, but so now I'm going to ask the question, what's F divided by G look like? F divided by G. Okay. Well, F was x squared minus 25. G is 1 over root x, right? Okay. Now, algebraically, when I go ahead and simplify this, I think I should simplify that because it's a compound fraction now, multiplied by the reciprocal of 1 over x. 1 over root x, right?
Yeah.
So that's going to give me root x times x squared minus 25. And here's the thing. If I neglect this idea of what these domains should be, and I think I just got to find the domain when I'm done. Right there when I'm done, I think that 0 should be an option. Does that make sense? Because there's no division here now, right?
Yeah.
Okay. So that's the idea that I need to make sure that no matter what, your domain is A intersect B. So even though there's no algebra here that says 0 should be an issue, it is indeed an issue because this is what it came from. And it's an issue where I've got something circled there, right? Does that make sense? Okay. Doesn't look like it's an issue when I simplify, but because of what that simplification came from, 0 cannot be included. That's why we always got to say A intersect B. Is that okay? All right, so now if I do G divided by F, and this is the one I really wanted to get to. G divided by F of X is going to look like 1 over root X divided by X squared minus 25, right? Well, same thing, I'm going to divide by, or multiply by that reciprocal. So it becomes 1 over root X times X squared minus 25. Okay, so the domain should still be 0 to infinity, right? Because we say the domain has to be A intersect B. So that has to be the same as the domain for F plus G, F minus G, G minus F, all that kind of stuff. But it also said in division where G of X, which is X squared minus 25 in this case, which actually is our Fx, but if you go back to the definition in blue, it said G of X at the bottom function, cannot be 0. So where else do we end up with a problem for the domain here? At 5. If I plug 5 in here, I get 0 down here, don't I? Now, there's a problem at negative 5 as well. Why don't I worry about negative 5? Because it's not in A intersect B to begin with. Okay? So my real domain be 0 to 5, union 5 to infinity.